All right, guys. We're ready to start. I don't have a presentation or anything. I expected this to work like a forum session or typical OpenStack development PTG type discussion. I had seeded the Etherpad with a few little thoughts around what we would like to discuss here. The definition of the session is 1 to 20 total server footprint, which in my mind is about reducing the amount of resources on the edge. Does anybody have a different definition of what they think that means? Okay, so the Etherpads, just so you know, all the Etherpads are going to be linked on the websites next to the schedule where they go, so you can find them there. So my thought was that the core discussion of the thin control plane is how do we reduce the footprint of the control plane. And in my mind, that's more about the resource utilization of the services that run the control plane, the thinning of OpenStack, if you will. Now, the way we're doing that, and I would like to hear what you're doing, is through the OpenStack Helm deployment mechanism. And that mechanism is allowing us to define overrides that manage how much core, how much CPU memory, each of the, I don't know if you're familiar with that project. What we've done is we package the different OpenStack services, Nova, Neutron, et cetera, into separate Helm charts. One of the mechanisms of Helm is that you can define which values within the chart are overridable. What we've done with that then is allows us to thin down the resource utilization of the different services. We're also introducing the notion of overriding which part of a service you need or not. An example, if you're using the Nova chart, you might not need all the Nova agents that come along with it, or the Neutron is probably a better example of that. So there will be an override to turning on and off whichever service functions you don't require. They're also scalable independently. Yes?
So we talked about your thinning down are you talking just about the services in general, or are there other things that you're doing to reduce the resource utilization?
This question was, when we're talking about thinning down, there you go. Go ahead, ask it again.
When you talk about thinning down the control plane, is that just by cutting down the number of services that you're starting, or are there other things that you're doing to reduce that footprint?
Well, we're talking mainly about reducing the amount of services that we need. We're talking about reducing the resources that each one uses. We're talking about relying on the resiliency of that something like Kubernetes gives you, since we're running them as pods, and perhaps not need to spawn as many of each service as we traditionally do. Do you have the microphone?
Is it a question of reducing
Is it a question of reducing the resources that a given service consumes, or just controlling? Right.
It's both, I think, right? There's two aspects of this. One of the things that we've noticed, I was mentioning to somebody a minute ago, is that some things seems to be a bit resource hogs, even when they're doing nothing, or quote unquote nothing. So I think there's a little bit of work to go through the code and do some analysis of that to identify any of those hotspots in the resource utilization when they don't need it. So that's part of this as well, right? Do we need to do some? I asked some questions, and I know you're probably more familiar with this, but I don't know if in the CI/CD gating that OpenStacks go through today, is there anything analyzing the code in that way? Yes? I don't know, the microphone?
We have
Yeah,
somebody
yeah.
working for that.
Thank you. I think what you're describing certainly makes sense. What I'm thinking is how do we define minimum set that you got to have and then add others without interrupting the service? This is the key. Without interrupting the service, how do we add additional services? Can you comment on that? What is that minimum stuff that we got to stick? And what would be the size of the vCPUs, RAMs, and things like that? And then how do we deal with this without interrupting the service, adding the additional services?
So how we're addressing that is as it is, right? But what we were trying to get to this model where you're describing what you want to deploy through the data that specifies the overrides that go into the chart. And what that means is you have a Nova chart that spells out how Nova, and that chart might have some default values, default settings that go in there, but that might not work for you. So I don't want you to have to change the code that describes how Nova and its functions are deployed. Instead, what we're giving you is a mechanism through which you provide overrides that say, well, I want to have 3 schedulers because I know that I need 3 Nova schedulers to do what I need to do, to support the loads that I need to do, or I need more than one placement API, or whatever it is that your particular setting needs. So you're doing that through overrides. That's what that tool that I mentioned before, Armada, allows you to do. It's a mechanism through which you can deliver the data that describes how you want your deployment to be in terms of resource utilization and configuration without changing the packaging. It's one package, works the same if you provide the data that says, I want 3 schedulers, 1 scheduler, whatever. And furthermore, it gives you a mechanism to do what you just said. Since all of this is running as containers, running as pods on top of Kubernetes, what it allows you to do is the same thing that you do with Kubernetes today. If you're familiar with that, you can do kubectl, add resize, if you will, and add another, increase a replica counter of some deployment set. But you can do that through this today. It means I got 3 Nova schedulers running, and you add 4 or 5 more if that's what you need at a particular point in time. You can even deal with bursts, right? You can say reduce to, add 3 more of this particular function, get some more. Now, of course, maybe it's a little bit naive. Not everything is going to work well with that, and that's where the software might need some tinkering to be able to deal with the ability to increase that. But the layer, the foundation to do that, it's there. It's what we're providing today.
Yes, Qasim here. Actually, I have a couple of comments. First of all, where we are talking about thin control plane.
Right.
So first we have to think from the edge use case point of view where we need that control plane. Because there can be a situation where we might not need a control plane. We just take the approach of remote compute. Because if we just put a compute at the edge and the control will still reside in the central side, that can be one way of looking that side. Then from OpenStack point of view, if we look into the components which actually take action and then stay static. For example, Nova just create VM, Cinder give the block storage. Then the networking piece is always there all the time. So we actually have to identify out of so many different OpenStack projects, which project and components are just are in the mode of creation and then get out of that mode later on. In other words, they are not actively making changes in the workload. So based on that, then we can think about those modules are required for the thin client or the thin control plane side. So basically, there can be a thin control plane, which can be aggregated control plane for multiple sites. And it may be possible the thin control plane will reside on the small edge side as well.
Yeah, I don't disagree. I think there's use cases for both, right? You're going to find that there are some workloads that need constant tinkering. You need the control plane to do something with them all the time. So the risk of detaching the control plane aspects from the compute aspects for those workloads is great, right? If there's no communication between the control plane center, let's call it, and that edge, and you have a problem. But there there's definitely, if you remember the slide that Camden shared this morning, there was this layering that got you closer and closer to the customer, right? And the delay, the latency that you needed to support was smaller and smaller as you got closer. I think that case that you described is something that's going to push you away, right? We talked about that edge. I think in what he called the edge, it talked a scale of thousands of locations. I still believe that there you're going to need there's value of still having the control plane, but when you start moving further away, that's where maybe investigating into that notion of decoupling some of the control plane functions with a compute node in a separate location might have value. There is implications to that, right? You lose some certain things besides there's a notion that now developing and testing introduce other complexities that you didn't have before. Right? When you can deploy this whole thing as one unit to say, here, go deploy this thing in your laptop, or here, Juniper, go deploy this in your labs and go test your VNF. There's a lot of value to that, whereas today, you know where we're at, where it's hard to test some VNFs because you don't have the same conditions that we're providing in our network or the other way around. So this gives you, I think, the edge in a box, if you will, has a lot of value for the whole life cycle of the development through production.
Okay. Yeah, one more feedback in terms of thin control plane from OpenStack. As if whole audience, can we actually point out these component is the minimum required? For example, Nova Compute. Then what else is the minimum? First of all, we identify those projects. Then we identify those resource utilization in Helm charts. What are the CPU utilization for that?
I mean, that might make sense in my mind if you at the same time categorize it into what kind of use cases you're trying to solve.
Okay.
Right? Because there might be some edge where you need some projects that you don't need in others. So maybe there's a minimal set that's common across, obviously, but there might be some cases where there's a difference. So maybe if we, I like the idea, the table, but then maybe categorize it with what kind of use case you're trying to solve with this minimum set.
So maybe we can take different use cases. Based on that, we can create a matrix. Okay, for this use case, this is the minimum control plane requirement. And at least we start documenting, and then once we test those things, then we will be close to reality to find out how it behaves. And then that will actually give us a little bit more insight how things will look like in the edge. So what do you think about that? Yeah.
There's a set of Nova services that everyone's going to have, regardless of the use case, right? Nova API, you can't inject anything, so you've got to have that, right? I think that's what he's saying. But like Nova Console, if everything is, headless, then you don't need to run the console. Right. Whole part of Nova that deals with the console.
I don't think it's just internal to Nova, though, right? What they're saying is, if you had a small control plane, you wouldn't use Swift as your backing store for glance. You'd just use file or whatever. But that should all be documented already, and if it's not, it's just a bug. It's not a big deal.
Do we have I agree. I don't think it's a big deal, but he's looking for a table probably.
Yeah, well, he said Nova components. That's why I was drilling down on it. But regardless, a lot of the things that you were saying earlier seemed to be maybe decisions that were made by the deployment thing that you were using, and that's why you need overrides to get it to not do that. And I think it would help at least me from being down at the project layer to distinguish between things that need to change that might be assumptions in some deployment tool that's being used, right? Versus something that Nova requires you to have Nova API because you got to have Nova API.
Right.
Nova does not require you to have Nova Console, but your deployment thing might, and maybe that's one of the things that.
That's a possible override to make that decision.
Right, but that is purely.
It's just about how do you deploy the project. It's not about the project itself, but.
Right, but I mean, like, if your deployment thing assumes laying down 50 Nova consoles or whatever, that's just an artifact of the deployment tool that you're using, not necessarily the deployment tool that somebody else is using, right?
Right.
That's all.
Okay.
I absolutely agree with that. We take.
Can we just start with little bit of the use cases first. I mean, I know you're from AT&T. NFV, edge box is probably pretty big. We've been struggling with how to extend OpenStack to things like really, really small devices like Raspberry Pi-ish devices, and how can they interact and play with a cluster of VMs, for example. So, extending the control plane or minimum set of control plane APIs that really small devices can interact with. I'd like to see that as a topic.
I don't know if anybody else wants to address that one. So I've seen some prototype of OpenStack running on Raspberry Pi. Was that you guys? Or?
Probably not.
No. So.
But that's pretty heavyweight to run on, our Pis, right?
A test. I've seen something in a blog or somewhere.
In regards to minimizing the hardware footprint for OpenStack, I mean, a lot of things have been tried. I've seen it running on Raspberry Pi. I think it was Vancouver. They had it. It was a neat trick, but it really didn't do anything. We bring Horizon up, and it was basically just the control plane, and it was barely there. So I think we have to ask, like, what is it that we're trying to do with Raspberry Pis, and what's your motive? What's the driver? What's the use case for going that thin? Do you have applications that are going to run in that type of hardware and in that type of environment?
Yeah. What is the value that that's bringing, right?
Right.
Yeah.
Right. Other than it's a neat trick.
Somebody behind you there.
For my case, it's just I'm not sure OpenStack can support those kind of small systems, but from customer cases, we do find out it is definitely required for have smaller devices can be supported in this kind of cloud edge computing devices. And in these devices, the small hardware, small CPU, small storage are quite common. It's not necessary to have a big servers. And I'm not sure how down in the future OpenStack can be supported over there. And also, number of devices typically in the edge computing could be huge. What I mean huge is not necessarily thousands, could be across the 10,000, even more than that.
Just to continue on the same thread, like he was saying, is there are telco cases where the physical locations that where ENOBs are located could be poles. They could be small, tiny closets. They could be sites that have been abandoned for years, and they have small power footprints. And these are perfect sites for. And I'm not going to, let's say like a set of NUCs, or that type of small form factor where there's no running fans and minimal airflow or air conditioning, and then there's sites where people want to attach them to poles. There may not be a physical location in that edge site. So I think there are definitely cases for small footprint hardware, but I think some of the things that we were writing on the Etherpad is defining reference architectures from either use cases, or either the hardware is going to drive what you're going to need to define OpenStack as the control plane or the minimum footprint, or the workload is going to drive it, and you have to size the hardware, try to figure out what hardware can be used in those type of situations.
I think that's partially what Kasim was getting at, right? There's some scenarios where do we really need to decouple the control plane to support those cases where the footprint is so small that you really have to optimize or maximize what you can get out of there from compute aspects. And so I guess we do have to tackle that problem.
Earlier, you had commented about the presentation this morning, I think from AT&T, the sort of scale of tens or hundreds on one end of the chart to the left side being millions or billions of devices. And then you made the comment that the edge might be somewhere on the right. I think it's much closer to the left than that. Not Like, I don't see a use for OpenStack scheduling workloads on my cell phone or my, glasses, but definitely to the next hop in the network from those connected devices, whether that's my Wi-Fi access point at home or something on the cell tower physically there that might be as small as we would consider, say, 4 servers today. Those 4 servers, if we want to talk about a thin control plane, we could either say, of those 4 servers, what percentage do we have to reserve? Can we describe that, say, using Helm as 5% or 10% of those machines' resources? Or can we offload that even further and say those machines on the cell tower, on the whatever, the next hop in my network, they are available, addressable compute resources for whatever application needs to run close to what's on my device or the drone flying around. But the workload on there is orchestrated by something that is connected to tens or hundreds of those. Right? So could we have a control plane, the Nova, Glance, Cinder API endpoints, and all of their logic running in a data center that in turn is connected somehow securely to 100 points of presence around one city? So nothing is more than 2 milliseconds away. Could we do that?
That's a decoupled case, right? That's what I was talking about when I mentioned the regional, exactly that. Yeah. Yeah.
Okay. Yeah. So I think we need that.
Yeah.
Well, I'm not convinced that the phone is not an edge compute. I've got 8 cores in here. Next version of it will have machine learning, so it's going to have a GPU in it. It's 8 cores, plus it's got the display logic and whatnot. It does Bluetooth communications. It does Wi-Fi hotspot. So this thing here is more powerful than an original Cray. And so it can control other devices. It can be an edge. And so we do have
So do you believe in pushing the control plane all the way down to that thing?
You will need...
Or it's a variation of what he was just explaining, where maybe this is the next hop where your control plane is.
So workload will be here, but there'll still be like, it'll do data reduction. This will do its own data reduction, but it still will push up concentrated information and ask for information in return. So there will be probably multi-cloud kind of communications in many instances, or cell type communication.
Yeah, I mean, I agree. I mean, I don't think that it's one or the other. It's all of the above. So, I mean, there will be use cases for only independent edge cases, because there will be those cases because you have over-the-air cost, latency, or what have you. And there will be hybrid, that you want to keep something there but push something else. So that's why it's more of use case driven, I believe, and rather than technology driven. So I would try to step back and don't think how I can take the current OpenStack to strip it down to the bare essentials, and if I can fit that to the edge of the mobile, but maybe try to see that we need to architect platforms, edge platforms, for all of the above use cases. And the power is to how we can flexibly, with tools and control, create a universal control plane that could fit
both use cases.
All use cases. The autonomous independent, the hybrid, or the one based on the first hop.
Yeah, I mean, the way we've been thinking about this is OpenStack is running on top of our undercloud, running those VM workloads. When we're talking about the container workloads, we're thinking this undercloud, Kubernetes, or whatever, is taking that role that you're expressing there, right?
So from as all the Nortel DMSs start getting pulled out and all of the old central offices become data centers, from a disaster recovery perspective, what's kind of the better model? The old central office being the edge, or should it live in the access point itself?
It depends, dude. That's the problem with this conversation. For some people, you know, your little device is on a pole that has poor network connectivity and you want to push as much out as you can. In other cases, you have really good connectivity. Like if you've got a fiber to the node cabinet on the corner of a street and you've got gigabit copper to CPEs, you could have a centralized control plane on the street corner, right? You don't need to push it out to the devices. I think the problem with this session is we haven't worked out what the use case is. Like, what are you actually trying to do? How do we get you there, right? Yeah, and what doesn't currently work, right? Like, so as an OpenStack developer, I'm sitting here and there is nothing actionable for me in this discussion, apart from, like, maybe we could write a doc telling you what services are optional and you don't have to run them. But if we can have, it doesn't have to be one, but a small number of really concrete use cases, then we can actually go and do some research and be more helpful.
I think the use cases is the first part, and the second is the reference architectures. Yeah, right. We apply them, reference architectures, to the use cases, and you know, the ArchDocs contributor, the sole one now, you know, we're always looking for different use cases to come up with architecture solutions to, but if we never have any use cases, then we can't write anything. So I think, and as I wrote in the Etherpad, is we have to define, and this is a complaint I'm hearing throughout the industry, is everybody keeps talking about edge, 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 right? They keep bringing up the same 4 use cases: IoT, automated vehicles, yeah, exactly, and then it stops there. Everybody stops talking. And it's like, well, okay, what are then the requirements for those 4 use cases? Where do the edge sites have to be? What do they have to look like? And in reality today, what infrastructure is out there? What are the telcos using? What are the other service providers? What are the cable companies using? What are the traditional infrastructure providers? What do they have available for edge nodes? And I think working on that first, instead of saying, we're going to attach them to every light post and every bike helmet, I think that's more future. But I think if we can define what the edge is and what the main use cases are, I think that would drive then some of the development.
I think maybe in this discussion that we should start naming the use cases, and we had 2 that were. I mean, we had one that was named in 2 talks this morning, right? We had we had these cloudlets. Is that what they were called?
Cloudlets.
Yeah, the cloudlet, which is a box that has some number of CPUs inside of it, some sort of fast network connection, and it's distributed at a location with high power, right? That's our first use case, and we've seen instant. I mean, you can, the orange box, right? You can go get one from Canonical, or there's a company in London that sells them. So that's one use case right there. And I don't know if anyone else could name any others that they've actually seen in production or they're using right now. But I think it's. Yeah, I don't know, but I think it's instructive to name.
But I think as an abstraction, as a cloud in a box, it makes sense.
Some actual things, right, that we can do. Like if we keep talking about like 20,000 use cases, we're never going to drill down to actual limitations currently or requirements or whatever. So if we could just pick one for the purposes of the discussion here, and if anybody has like.
I mean, I'm pointing that as an example of that is one that is in production right now, and you know, I don't necessarily run one, so I don't know if I can talk about the challenges associated with that. But there should be people here who can.
So I would like to little bit go from service provider and telco cloud point of view. So today we have done in telco cloud virtual EPC. So that has multiple use cases from LTE subscribers to different streaming services that will go through virtual EPC site. But from edge point of view, now the discussion has started how telco cloud will impact the RAN sites. So you can imagine all the existing service provider already have their transport network, they have their cell sites, they have the tower antennas, and the physical boxes, RBS, eNode Bs, they are physical boxes there. So where now this whole trend is going, which is a very solid use case, is from the virtual RAN point of view and 5G point of view. So in my opinion, if we have to take one use case, that would be the best example, and that use case has more relevance. And if we figure out how those 5G RBS or eNode B software, when it's virtualized, how it will look like, because definitely it will be another NFV. Because we have done a lot of NFV integration in telco cloud. When the 5G RAN is available in a form factor of a virtual machine, either it is in a Kubernetes form factor. So the biggest thing OpenStack has, even Kubernetes has, the orchestration piece. So here, our all discussion will be around the orchestration side. So what is required for those workloads to be orchestrated at the edge? This is first part. Once those workloads are there, then the next component is the networking piece, which is keep changing all the time. Because in all the OpenStack component, Neutron is the main component which is highly touched in the application processing point of view all the time. So then we have to see, once the workload is there, what are their workload needs are. They have to do the operation and maintenance. They have to collect information and send it out. Then we have to further figure out either that remote cell site, either there are 5 sites or 10 sites. Does each site require a control plane, or can we push control plane to the next, or create an aggregated control plane for multiple sites? So in this way, we have to figure out where the actually trend is going and what actually application available in that use case. That would be my suggestion. If we can take 5G use case as a reference, that would be one thing.
All it has to be is compute nodes at a cell site, right? We don't have to get into too much detail. I wouldn't think 5G, 4G, or 3.5G, but like
you can take that as a given, right? Compute's not at the cell site.
That's what I'm trying to get at. So what is the desire? Is the desire to have no control plane there? Is it reasonable to have like one quad core machine there to be a control plane for 4 compute nodes? Because
I think what I've heard is that the desire is unfortunately both. There are some cases where the feeling is that you will need the control plane sitting there next to those machines. And there's others where you can decouple it. Control plane can be remote, so you manage the compute nodes only.
So I want to know what the requirements are for like API latency, unified API view. Like if you have to have a unified API view, then that like sets a whole bunch of things apart. If you don't mind hitting a dedicated API for a cell site to spin things up, like a REST API, I mean, Nova API, then that's a whole different ball of wax than like I need a unified Nova API in front of all of my cell sites so that they all look.
Yeah, maybe I could give like a worked example.
But by unified, you mean kind of like a federated Nova API that manages multiple cell sites versus talking to each cell site. Yeah.
Yeah, I'm going to stand over here because of feedback. But let me give a worked example of what I'm trying to get to. Hi, I'm Michael. I'm an OpenDev. I'm a grumpy old man. I had a coffee with some people from an Australian telco I won't name because they didn't tell me I could. And what they have is fiber to the node cabinets, and they can't keep their back-end bandwidth growth. That doesn't keep up with customer use. So what they've got is these cabinets with spare compute on them, and they want to sell VM slots on those cabinets to Netflix to push out CDN nodes, basically to the street corner. Your Game of Thrones comes from 100 meters from your house, not from some centralized data center. So that's the use case. In that case, for example, once they've bought the VM slot, they never ever manage it again, right? You've bought that time slice in the node, and it's there until you cancel your contract. So it doesn't matter if the control plane's offline for long periods of time. right? Big whoop. So maybe the control plane doesn't need to be near the node. If the node can't talk to the centralized control plane, then you know what? The node's actually probably offline anyway because we dug up the fiber. So if we could come to a small number of use cases like that, like I want to push CDN VM images for my customers to cabinets on street corners versus I, for some reason that I can't figure out, want to run containers on every customer's modem, then I don't actually care what your specific use is, but if we can come up with a couple of categories of usage, which is what I'm calling a use case, then we could sit down and say, oh, okay, that's interesting, right? We think the least crazy way to do that would be this. Otherwise, we're just going to go backwards and forwards forever and never actually help y'all all. Oh, God, there's 3 of you.
So that's very similar to one of the main use cases I'm working with, except instead of video streaming, it's data processing. There's a bunch of things somewhere that are generating data, and what things are online varies over time. The sort of central data processing platform for this Internet of Things can recognize that, oh, there's a whole bunch of devices that are now coming from this city, but I don't have any processing power near them. They have to transit 4 hops across the Internet to get to the next VM that's processing that workload. I'm going to spin up a VM to process that data closer to them. In that situation, the availability of the control plane and the availability of the VM are tied together, right? I have to be able to dynamically say, oh, I need to make a change here. 4 hours later, the data is not there anymore, so take it down, spin one up over here. Right. If in the ideal state, that cloud could function by itself if it's processing data and the things over there can talk to each other in that cloud. Yes, yes. So having the local API endpoints for those resources is useful in some cases, but I think most cases that I know of are served enough by having a central or shared API and a bunch of compute closer to things, like what Michael was describing. That's
Why does the single control API not purely
the single API simply reduces the amount of overhead, right? My assumption is each of these edge compute resources is relatively small, and OpenStack's control plane, unfortunately, it's busy a lot of the time, even when nothing's happening. So if we can move that, my statement earlier was 10%. It's actually probably higher than that for a small number of machines, but I'll pass the mic on.
So this is where the cloudlets and some of this stuff comes on. Actually, what I think we need is a control plane proxy. We need to be able to hand off the ability to do control to some of the closer to the edge machines. And so what we really need is yet another way of saying, I'm controlling the VM provisioning now because I'm on the edge and I have connectivity and it might go away at any point from the central office. Or the central office is overloaded, so let's offload the provisioning to some of the beefy edge computes like the RAN computers. And so then we need a way to negotiate who the proxy holds a proxy for the control planes and be able to identify, verify, and switch.
It's kind of like a distribution layer, really, right?
Yeah.
So I've been working on virtualizing the packet core for the last 2 years. Most of the applications that we have is like monolithic applications. They consume a lot of vCPUs, and they're not designed for the edge computing. So this will, even like vendors like Ericsson, Cisco, and Nokia, especially for telco, they'll have to relook into the architecture into a more microservices architecture and distributed, where let's say certain data plane virtual machines can be pushed to the edge, but the VNF or the cluster of VMs that's doing CDR or O&M, it's more at the core or at the center. So this helps better edge computing than putting like one VNF at the edge that occupies, like, let's say, 600 vCPUs. So we also need a way that OpenStack, between two different control planes, the VMs can communicate. That is really required in this edge computing to take off.
And exactly that type of architecture is possible with the remote compute. So you have a centralized data center where your all control plane is. And the remote compute actually will have your workloads. And even you can have a distributed VNF type of architecture with this approach as well. And overall, one more thing here is, as far as the control plane is concerned from orchestration point of view, once the workload is instantiated and workload is there, it is processing. So the data plane actually, which is more affected by the latency and jitter. The control plane, once the creation of the VM happen, and then it start processing the subscriber or the user plane data, and then it is in a static mode most of the time, except the creating the VM up, down, and some of the statistic collection, which is going to the central data site or control plane side. So, so based on that experience, so my understanding is this: thin control plane as well as the remote compute. These two things are important in the edge computing. And based on the use cases, one can actually decide based on the architecture and design, does it has to use a centralized control plane based architecture, and is the applications are actually designed accordingly, as he mentioned. And then the vendors will also get an opportunity to redesign their VNFs, where they will actually have a distribution of their internal software based on the functions they are processing in the network. So CDR's function, which is more not latency and sensitive jitter, they can put it in the central side. And the data plane processing for GTP and other signaling, not signaling, the data plane processing traffic, they can put at the edge side. So that's my feedback.
I mean, in my opinion, again, I hear that there are use cases. I agree. Okay, we said about use cases. And there is the close to the edge, I would call it, use case, which is the cloudlet, it's the run side, is all these cases. It's not, in my mind, it's not edge. It's close to the edge. It's, as they said, one hop from the edge. And it's a family of use cases. And it might scale up, because I think scale, we didn't mention until now, but in the control plane plays a real big thing. And in that close to the edge, we might be at the hundreds or thousands in some use cases. But if we go one step further and we think the actual edge, and let me bring you an example, right? I'm from Inmarsat, and what we offer is satellite communication with a terminal to the end user in a global way, and that could go up to thousands and thousands and millions of terminals, and could be providers with similar use cases, with edge devices. And if we really want to push something there, and for some use cases, let's take my example, which you have a satellite link, which is very expensive, it makes sense to put something, a VNF at the edge, to save the bandwidth. In a terrestrial provider might not play such a role because I have it. It's not so much of a cost. In a mobile provider might play a role. So, and this is, I think, the edge use case, which we need to have a thin control plane at the actual edge of the network. And this cannot be with an agent or a no control plane, just a compute there, because this needs to have control plane on its own, because we have unreliable comms, which will have a disruption of the connectivity. So that is the extreme, in my opinion, edge use case, which will drive different needs for the control plane, which again, both are valid use cases.
That is exactly, so both approaches will go hand in hand. So both approaches will go based on the use cases and where the actual application is, and what the actually requirement for those application in terms of KPI and SLA for their performance. So those things will also come into the consideration. But high-level architecture, we can categorize the use cases which require just a compute, and the use cases which require both compute and the control at the. So.
Just to add something, I think also that we are talking about control plane, scale, and decentralizing that towards the edge. I think hierarchy of control planes briefly was touched in a comment. I think it's important. So delegation of control to the lower tier of the edge. So a centralized control plane that delegates to the run, and then that could delegate further down to the edge, and hiding the abstraction is important for tackling the scale. We cannot assume that in the visionary edge use cases of the thousands and millions, we will still have one API, a central point of control plane, which might be efficient, but it works for some scale, but after a while it will be out of control. So this...
Here.
I want him to talk for a second. Can you give me a concrete example of an operation that you mean delegating down to the lower layers?
So, right. So I can imagine that a central global orchestration doesn't need to have all the policy and all the details about how to orchestrate a VNF that lives at the edge. Doesn't have to have the state of that in the granularity of, I don't know, the policy for scaling up the VNF which lives at the edge. This is a local, so the authoritative domain of control for a control plane could have its locality, which doesn't have to bother up the higher tier of control. So I start to think such a thing. So I delegate further down the control, and I propagate up just an abstraction of the state. So having everything centralized and have a central point that I know exactly what's going on down to the last tier of the edge doesn't. I think it won't work in the scale that the edge computing is heading to. We need to have a little bit more autonomous control plane as we go towards the edge in order to support that thing, the scale of the edge use cases.
Yeah, that was not very concrete for me. I might be too far down at the lower layers to process what you said, but I still want to know whether you're talking about heat at the higher layer talking to multiple novas down at the bottom layer, or if you're talking about delegating within one particular service down to, building that hierarchy within a service, or if you're talking about that all as something that the application uses service catalogs to drill down and find the endpoint for the thing that's on the street corner that is going to have the Netflix cache CDN in it.
I think the earlier gentleman said something about the heat and the NOAA. The granularity of the resource and resource types is an issue for scaling in and out. And that's one of the reasons we had Senlin pop up in the OpenStack, I believe, where you have the scaling out, etc., addressed by the two aspects. One is the resource type being single type, that is, you don't mix up like flavor types, and the second was policy. So that's one of the possibilities that we explore, the policy-based resource granularity to a single type, like I want to do only compute, I only want to get bandwidth, those kinds of things, which is critical at the edge, whether you call it cloudlet, whether you call it whatever, a host, bare metal, or even you put a container or whatever the form factor. But that should be selectable. So heat has some issues, something to learn from Senlin, I would believe. But That's all I have for now. Maybe you people are better informed on this too.
All right, we have a few minutes left, and I think we want to try to get something concrete out of this. From you guys, I'm hearing you want to find use cases that are more concrete, that actually give you something to go attack the problem. There's a few hands back there.
So maybe I can take just the mic a few seconds. Yeah. So I'm Adrian Leb. I'm leading the Fog and Edge massively distributed cloud team within the OpenStack. So typically in Boston, we presented a one-wide evaluation of OpenStack. So that is, we have everything in the control plane, everything is central, and we have only compute nodes. And we evaluated the impact of the latency when you want to provision a VM and so on and so on. So I think we made the same issue that we are doing right now. We just focus on Nova. So basically, Nova, for example, with the cells, the cells approach in somehow a way to delegate. You have the master cells, and then you have the child. But we should not focus only on Nova. Because typically, without, for example, Cinder or without Glance, you do nothing. And we currently are doing preliminary investigation, and I can tell you that if I want to put my VMs with a remote attached volume, which is just 30 milliseconds far away from my edge node, it will take 200 or 300 seconds. So that means that if you want to boot your VMs, you will have to wait 300 seconds before having your VMs, 5 minutes. So if you want to target some reactive applications, some latency critical applications, there is no way to do that. So that's been a reason that we should first identify which components can stay higher in the infrastructure, which one should be at the extreme edge, and then investigate the impact of the latency when you want to provision some VMs, container, whatever. So typically, the idea is to run the Rally benchmark suites and give a look to what's happened.
So clearly to me, from what's been discussed here, that remote case is something that needs to be architected through and through, like you're suggesting. It's not just a Nova problem, it's across the board. So that to me is a concrete thing. We need to come up with a blueprint of what that looks like, because there's plenty of use cases. There was both cases, right, where you wanted to thin and where you needed that remote access. So we need to understand how that's going to work.
Yeah, I would like to comment on this Nova. So for example, Nova is the creation of the VM. Once the VM is created, so the actual VM, once it created, it is hosting an application, which actually do the data processing. That is more important for latency and jitter from the subscriber point of view. I understand the orchestration latency will play a role, but I don't think once the workloads are being created, that latency matters. It matters, I understand, but from most important thing is when the subscriber, when the application is up, and the subscriber is getting processed its data, the data plane latency is more critical. So even if we go to our keynote earlier, the most important thing we were talking, when the devices actually offload their data processing to the edge. When the data processing is going to the edge, they are not creating a VM via Nova and waiting for 30 millisecond latency. The assumption is that workload and packet processing application is already instantiated and it is already there.
You're right, but we're trying to get some concrete actions regarding the thin control plane and what it means on the edge.
So maybe I can highlight just an ongoing action we are doing in the Fog and Edge working group, so which is related to the use case. So unfortunately, I'm not the guy that are leading that, so I don't know whether Paul Andre is in the room or not. Maybe attend another session, but I invite you to go on the Fog and Edge team wiki page, and you will find some links through our Etherpad. So we are used to have a big weekly meeting, and you will find some link to a Google spreadsheet where actually we try to categorize use cases and what are the possible deployment scenarios, such as everything in a central DC and remote compute, or such as which will be completely distributed using region, using the cells, and so on.
Can you put the link in the Etherpad? What's your time check?
So I think just to give a comment for the use cases. So we are working on the IoT in the cases. I think most of cases, those edge computing devices are sitting remotely from, I think it's globally distributed. And in this case, the two assumptions is remote, and also most of the edge computing devices are kind of not like high-end computer servers. So that's kind of local autonomous kind of administration is needed. The second thing is since it's global distributed, there's a kind of architecture, hierarchical architectures, because all the services need to be global distributed. At the same time, there's a regional kind of requirement to be able to manage, to administrate those kind of devices as well, for the local kind of management and the local regulations requirements. So those are the things I think kind of required for the edge computing. But for the service-wise, definitely that's more like globally distributed, even in most of the cases. So from my side, I will say the remote management and the lightweight control plane, as well as those kind of consistency for the management globally as well.
Did you capture the distribution layer discussion? I thought that was an interesting point. There was a minor thing that I think could be worked. I don't know if you guys are working. Is when you're running the control plane as containers, and you're running certain functions on the compute host as containers, besides the Nova agent and things like libvirt, but we also can be running. If you were running something like Contrail, you put the vrouter agent and so forth. They're containers. They're using some resources on that box that I don't think Nova is aware are being used in the box when it's looking. So something like you need a filter that takes into account whatever Kubernetes is using on that box, compute host perspective. Nova is assuming the only thing on the box. So it's a prescriptive thing beforehand, but it's not a learning the type of thing. We're done? All right, thank you very much, guys.
Yeah, so we're about to move into a 15-minute break. This was actually the first of 3 thin control plane sessions. If you take a look at the schedule, we have another one starting up at 2 o'clock and another one at 3:15. This one kind of turned into, I think, a more generic thin control plane session. So some of these discussions might spill over into the other sessions. But everyone, thanks for your lively discussion, and I'm gonna try to write up some of the deliverables and some of the things that we talked about here, so that we can present that to the Nova community in general and to the edge community at large. So thanks everybody.